important, okay? So here's our y-axis, x-axis, okay? We're just continuing our lesson from yesterday, and I'll do all four so you have examples with different types of situations. The first thing we're going to do is graph f of x. Let's do it by graphing first, then we'll do it algebraically. Okay, so you know the vertex is, let's write them here, -1, -3. That's our vertex. So -1, -3. Well, when x is 0, this is 1 minus 1. Okay? X is 0, this is no something, yeah, -1 looks good. We can get the reflection point over, there's the axis of symmetry here, right? Just running through there. So we can get our reflection point. When x is 1, y is 2 squared is 4, 4 is 8, 8 minus 3 is 5. So 1, 2, 3, 4, 5. And we can get the reflection point. So let's draw it. I'm just going to make sure I didn't make any mistakes because those kind of kill the flow. 1, 2, 3, 4, 5, 6. I just substituted in myself. So when x is 0, you know the vertex is -1, -3. When x is 0, y is -1. When x is 1, you plug it in and you solve for y, and I got 5. And these points are reflections over the axis of symmetry, right? I just reflected. If there's a point 1 unit to the right, there's a point 1 unit to the left. If there's a point 2 units to the right, there's a point 2 units to the left. So we just write it like that. Okay, so now we're in a position to do the inverse function. If you know the vertex is maybe we should get these points down and then we'll be able to draw them. This point is -2, -1, a reflection of 0, -1, and this point is -2, 5, which is a reflection over the axis of symmetry of 1, 5. Yes? Did I hear a question or am I imagining things?
-3, not -2.
Thank you. It's hard to hear with these headphones on. Although it's hard for me to hear at the best of times, so what can I say? Okay, so let's now do the reciprocal. So if the vertex is -1, no, yeah, right, -1, -3, the inverse of that is -3, -1. So 1, 2, 3. I'm going to do it in another color to help you see it. I'm going to do it in red. So the inverse of this is -3, -1. 1, 2, 3, there it is right there. Inverse of this is -1, 0. Inverse of this is 5, 1. 1, 2, 3, 4, 5, 1. Now inverse of this is 5, -3. 1, 2, 3. And inverse of this is 5, -2. Oh, what did I write here? Something's... Oh, okay, that's not a point. This point is -1, -1, so the inverse is... No, this point is -2, -1, so the inverse is -1, -2. Yes, now we're doing better. So here is... our reflection, and that's the reflection over the y equals x line, which runs through those points there, and I'll just draw that in. They ask us to draw it in, so let's draw it in. We will draw it. We will follow instructions. y equals x. Label your graphs f of x, and this is the inverse. So we actually did part B here. If you recall, on the first page of this, we're going to find the inverse algebraically now, and that was part A. Can I answer any questions, or just can we take a moment if you have any questions? If anything on here doesn't make sense, let me know. Sure. I'll be happy to wait. The red graph, I used 1, 2, 3, 4. I used all of them. All the ones I listed here. See, these points are from f of x, so I just flipped them. So I used that point, I used that point, I used that one, I used that, and I just flipped it. Okay, let's now do it algebraically. So I'm going to replace f of x with the y, and that's 2 times x plus 1 squared minus 3. So to find the inverse, we swap the x and a y. Let's solve for x. Let's add 3 to both sides of that equation. Let's divide both sides by 2. Let's take the square root of both sides. So we can write y equals plus or minus root 1/2 of x plus 3 minus 1. Or now let's return to the original notation. We just substituted y for f of x for easier algebraic manipulation. Okay, that's the inverse algebraically. Now, let's do domain and range of each. So just looking at it, can you tell me something? Is the inverse a function? No, it's not, right? See, if I do the vertical line test on the red graph or on the inverse, it's not a function. And that's because f of x does not pass the horizontal line test, right? It passes the vertical line test, so we know f of x is a function, but because it does not pass the horizontal line test, we know the inverse of f of x is not a function. It didn't pass the horizontal line test, right? And that was mentioned here, where it talks about the horizontal and vertical line tests. Okay, so we draw a horizontal line and it hits 2 points, then the inverse is not a function. So look at the inverse and we see that in fact it's not a function. So let's do the domain and range. So that's going to be part C. So for f of x, the domain is, it's easy to find the domain when you have a graph, right? X On a parabola or a quadratic function, you know that domain is anything, any element in the set of real numbers, and y such that y is greater than or equal to -3. So because we swap x and y, the domain of f of x becomes the range of the inverse, and the range of f of x becomes the domain of the inverse. So here we have this. Domain is x such that x is greater than or equal to -3. X is an element of real numbers. And the range is anything in R, right? Y such that y is an element of real numbers. So, another part of this question was, notice, I'll flip it back right away. Determine if the inverse of is a function. If it is not, restrict the domain of f of x so that its inverse is a function. Okay? So we have to go to this guy. We have to go to f of x, restrict this domain so that the inverse will be a function. So, for example, and how do we do that? We look at the axis of symmetry. The only way the inverse of this can be a function is if there's only one branch. So if I were to cross out this branch, can you see that this branch to the left went down here, right? Because if this point is -3, 5, this point is 5, -3. So can you see that this branch is coming down there, and the right branch is going to the top on the inverse? This goes here, the right branch goes here. So let's restrict it so the inverse is a function. So what we're going to do is cross this one of the branches off. It could be either the left one or the right one. So if we were to cross that branch off, we would be left with this branch, and the reflection of this branch is the top branch. So we're going to lose this branch. So part D is, how do we restrict the domain? We just use the axis of symmetry of f of x. F minus 1 of x is not a function. Okay, so we restrict domain of f of x to this. X such that x is greater than or equal to -1. That's the axis of symmetry, right? We're just cutting f of x in half, so now we only have one branch, and because we only have one branch, when we reflect it over the y equals x line, we only have the top branch. So then, with only one branch, you can see it passes the vertical line test. So x is an element of real numbers. This chops off left branch. Right? That's what it does. Now, you could have done it the other way, or either of these answers are acceptable. You could have chopped off the right branch. You decide. It's your choice. You could have done this. This would chop off right branch. Okay. There, we completed. That's the hard. I think that's a pretty hard one. Do you want me to go over anything before I move on to the next one? You know, we did it algebraically. We found the equation of the inverse. We did it graphically. We graphed f of x and its inverse. We stated the domain for both f of x and its inverse. And now we're just restricting the domain of f of x to ensure that its inverse is a function. Anything else we can look at? No? Okay, this one is tricky in the sense that when we find the inverse, it does a boo-boo that we have to correct for, and I'll just show you why. Let's graph them first. And I'm going to, oh, I did y already. I'm going to just use some easy smeezy points. So, you know, just to get us a basic graph of this, a sketch of this. So when x is 3, right, square root of 0 is 0, 2 times 0 is 0, this is 1. Now when x is 4, 4 minus 1 is 1, square root of 1 is 1, 2 times 1 is 2, plus 1 is 3. Now the other one, when x is 8, 8 minus 3, no, when x is 7, I think that's the better point. When x is 7, 7 minus 3 is 4, square root of 4 is 2, 2 times 2 is 4, plus 1 is 5. I think the next one we would have to go to if x is 19, but we don't want to go there. It won't fit on the grid. Okay, 3, 1, 4, 3, 7, 5. So this is 1, 3, 3, 4, 5, 7. Okay, let's draw the y equals x line, and this is f of x. This is our inverse. One, 2, 3, 4, 1, 2, 3, 4. Now, I'll let you catch up a little bit and do you notice, remember that inverses are congruent with the original graph. So notice this is congruent with this. F of x is congruent with its inverse. F of x is congruent with its inverse, right? They're congruent. They should look alike, but maybe just flipped around, and that's all there is to it. So I want to show you what happens when we do it algebraically. There's an issue when we do it algebraically that we have to correct for. So y equals 2 root x minus 3 plus 1. Swap the x and y. X equals 2 root y minus 3 plus 1. Let's subtract 1. X minus 1 equals 2 root y minus 3. Divide by 2. X minus 1 divided by 2 equals square root of y minus 3. Now we're going to square both sides to get rid of the square root sign. y minus 3 equals x minus 1 squared. I'm going to put a half in there. Squared. Minus. Just like that. I'm just rewriting it a little bit, factoring out the half. Too many exponents here. So y equals 1/2 x minus 1 all squared plus 3. Notice the vertex is 1, 3, 1, 3. But notice this is a parabola. This equation, this is only half of this equation. The other half is here, but that wouldn't make it the correct inverse, right? The equation has 2 branches, so we have to correct for that. We don't want that. And the way you correct for it is you restrict the domain of f of x. You just go the domain of the inverse. You go x such that x is greater than or equal to -1. X is an L. So what we've done, this is part of your equation. You have to restrict that domain or your answer is not right. Yes.
Did you just do with the domain? Why did you do that?
Why did I do that? If I don't restrict the domain, this without restricting the domain means my inverse is this. Right? Because this is a parabola. So I have to make sure this is not included, and I do that by restricting the domain. Oh, yeah, you're right. Thank you for pointing that out. My bad. X has to be greater than 1, not -1. That was important. Yes? Yeah, so the first thing I did was divide by 2. And then to get rid of the square root sign, I had to square it. See, in order to solve for y, I had to square it. Wouldn't you what? Okay, let me show you an extra step, okay? It might make it clear. Just let me get a piece of paper, and I'm going to show you a little bit more of that solution. Okay, so you're okay up to here. So I'm going to divide by 2. See, if I want to solve for that y, I have to square both sides, right? So I'm going to square this. Right, for example, what's square root of 5 times square root of 5? 5, right? So square root of y minus 3 times square root of y minus 3 equals y minus 3. And this is really 1/2 times x minus 1 all squared. And then you can solve for y. So that was part A. The graph was part B. Let's do the domain and range for each. Remember, the domain of f of x becomes the range of the inverse. And the range of f of x becomes the domain, because we swap x and y. It's a reflection over the y equals x9. So domain of f of x, we can just read it off the graph, right? X such that x is greater than or equal to 1, 2, 3. Right? It starts there, 1, 2, 3. X is an element of real numbers. And our range of f of x is going to be y such that y is greater than or equal to 1. Y is an element of real numbers. Let's do domain of the inverse, right? So let's just write it like that. Domain of our inverse is, well, y is is greater than or equal to 1. X is an element of real numbers. Range, right? See how it gets swapped? Range of f of x becomes domain of the inverse. Domain of f of x becomes the range of the inverse. Y is greater than or equal to 3. Y such that y is greater than or equal to 3. That was part that was part C. So the question asks, if the inverse is not a function, restrict the domain of f of x. Well, is the inverse a function? Does the inverse yeah. So for part D, we'll just say inverse f minus 1 of x is a function. Do you want more examples? You want? Yeah, absolutely. I'll give you a few minutes. Can I explain anything more thoroughly? Yeah, go ahead. Okay. Okay, here we go. Do you want 2 more examples? Some want it, some don't, so I will go with those who want it because... Okay, I'm going to use points to draw this because this can become quite headachy. If I do it using a series of transformations, it'll make it this too messy. So let's just pick some points. If x is, well, -3 gets us to -27. I don't want to work with that. So let's start with -2. That's -2 cubed is -8. Half of -8 is -4. -4 plus 2 is -2. What about -1? Let's go to -1. What is, so -1 cubed is -1. Half of -1 is -1/2. -1/2 plus 2 is 1.5. Let's try 0 will be 2. We'll try 1. 1 cubed is 1. Half of that is 0.5. This is 2.5. And let's try 2. 2 cubed is 8. Half of 8 is 4. 4 plus 2 is 6. Right? I'm just trying to pick some good points to graph this. Huh? Well, I think for the cubic function, normally I would say 3, but because these points are pretty tight, I extended it to 5. There's no hard and set fast rule for how many points. You just want to make sure your graph is represented well on the grid. So -2, -2, -1, 1.5, 0, 2, 1, 2.5, 2, 6. 1, 2, 3, 4, 5, 6. So let's do the inverse. We just swap these points. Notice negative 2, since x equals y, when you swap it you get the same point. So this is an invariant point. It doesn't move over the reflection in y equals x. This is an invariant point. Invariant point. Okay? Won't move because when we do a reflection over y equals x, if the x value equals the y value in any coordinate, in any point, when you swap them you get the same thing. So it's invariant. Okay, negative 1. Oh, this will become 1.5, negative 1. 1.5, negative 1. 0, 2 becomes 2, 0. 1, 2.5 becomes 2.51. 6, 2 becomes 2, 6 becomes 6, 2. 1, 2, 3, 4, 5, 6, 1, 2. I'm just going to twist it to graph it. Looks pretty much like that. I didn't draw it as well as I could have, but that's pretty good. This is the inverse. This is the original. I guess I got it there. That's good. We can just, they ask us to draw the y equals x line, so they ask us to draw it, we'll draw it. There we go. Notice if I were to fold this on the y equals x line, they would just land on top of each other. So we answered part B. We graphed the function and its inverse. Let's now do it algebraically. So y equals 1/2 x cubed plus 2. Swap the x and the y. X equals 1/2 y cubed plus 2. Subtract 2 from both sides. X minus 2 equals 1/2 y cubed. Multiply both sides by 2. 2 times x minus 2 equals y cubed. Now, in order to solve for y, we're going to have to take it to the exponent 1/3. I don't think you've seen fractional exponents. Right? We're going to have to take, because 3 times 1 over 3 is 1. So now y, am I missing something? No. Y equals 2 times x minus 3. Oh, made a boo-boo. That should be x minus 2. X minus 2 all to the 1/3. Whoa. So f minus 1 of x Alright, that's that for that guy. Domain and range is easy, right? On the original, on any cubic function, f of x, domain is x such that x is an element of real numbers. Range is y such that y is an element of real numbers. The inverse, well, the range of f of x becomes the domain of x, right? Becomes the domain of the inverse, and the domain of f of x becomes the range of the inverse. There, that was easy. Is the inverse a function? Yay! So part D, this is part A, this is part C, and part D we can say inverse is a function. I just, before I'll let you finish that, can I explain anything better? If you're uncomfortable with this, by the next unit you will be comfortable with it. I have a feeling. How many of you have seen fractional exponents? Some of you, not very many. You will understand this by the next unit. Kind of, it got, yes. Huh? Can you ask me tomorrow? We're finalizing it, so yeah. Yeah, sure. Here's your test. Here's page 1, page 2. Here are TI. No, I don't think so. I can maybe we can do some typical test questions. All right. Oh, absolutely. Ask me tomorrow. We will be finalizing it tomorrow. Okay. No fraction. No fraction. Please. Okay. Now in the morning class I drew this one using transformations. Did everybody finish 4? You got it? Okay. So I'm going to draw the final graph only. Do you notice this, the parent function here is the reciprocal function. And if you recall, I would hope by now when you draw y equals 1 over x, you know that y equals 1 over x, the graph looks exactly like this, right? You have 2 asymptotes, just like this. Agreed? You should feel comfortable with that by now. You have a vertical asymptote where x cannot be 0, right? Because you can't divide by 0. You also have a horizontal asymptote where y cannot be 0. Because watch, when you plug 0 into this equation and then you multiply both sides by x, you get 0 equals 1. This is not true. Therefore, y cannot be 0. So here are the asymptote. This is our, I guess you could say, our restriction. But when you label asymptotes, this is x equals 0. This is y equals 0. So I'm just reviewing that so that I want to ask you now, on this graph here, so we can do it in one step, can you tell me the vertical asymptote? Sorry, what is our vertical asymptote? So our vertical asymptote is x equals 3. What's our horizontal asymptote? Y equals -2. We get it from this guy. See, I can prove it to you. If I substitute in a y value of -2, I add 2 to both sides, and this is 0 equals 1 over x plus 3. I multiply both sides by x plus 3, and I get 0 equals 1. Not possible. This just doesn't, you can't say 0 equals 1 for obvious reasons. It doesn't equal 1. So My horizontal asymptote, no, my vertical asymptote is x equals negative 3, right? We can't divide by 0. So negative 3 plus 3 equals 0. So x equals negative 3. So I'm going to have this asymptote here. This is x equals negative 3. And my horizontal asymptote is y equals negative 2. They go up forever, right? Y equals negative 2. So now I can draw my graph. Right? There's a point there, there, and there. There's no stretches, so it's going to look exactly like this guy. It's exactly like this guy. The only difference is we shifted it left 3 and down 2. That's all we did. There's no stretches, no reflections. That's f of x. Can anyone tell me, well, no. Well, let's now do it algebraically so we can pick off the inverse graph. This is f of x. That's all we've done. We've only done that halfway. I want to do this algebraically first so you can pick off the asymptotes of the inverse function. So let's do it. Y equals 1 over x plus 3 minus 2. X equals, swap the x and the y. Add 2 to both sides. Oh, sorry, I didn't mean to put, my head jumps to subsequent steps in the solution, and I don't want to do that. Okay, add 2 to both sides. Multiply both sides by y plus 3. I need to solve for y, so I'm going to get rid of this. I'm going to divide both sides by x plus 2. And now I can solve for y. So f minus 1 of x equals 1 over x plus 2 minus 3. Okay, I realize I went fast. So swap x and y, add 2 to both sides, multiply both sides by y plus 3, get rid of the denominator. I need to isolate y, so I divided both sides by x plus 2 to get rid of this, so I could start isolating y. Subtract 3 from both sides, there it is. Now use the original notation in the question, so you should write it like that with the inverse there. Now, tell me, what is the vertical asymptote of the inverse? X equals negative 2. Remember, an asymptote always is an equation. So let's now draw it. This is the asymptote of the inverse right here. I'm going to do it in red now so you can see it. Okay? And what is the horizontal asymptote of the inverse? Y equals minus 3. It's an equation of a line, so you have to say y equals. Now I can draw my points in just like before. I better do it heavy. So the red one is the inverse. Ah, hard to find a good location.
So you don't use the points, you just use the...
In this case I did. You could have used the points, but if you see that there's no horizontal stretch or compression, there's no vertical stretch or compression, it's just going to look like the original guy. The invert, right? This is, yeah, there's no stretches, so it's just a matter of getting your asymptotes in there in this case.
What would it look like if there was, like, stretches? Like, what would the equation be?
Oh, it's hard to draw. Yeah, ask me tomorrow. You might, this I think we would expect you to draw. This is what we expected you be able to do on previous tests. I don't think, I will strongly object to any stretches or compressions in the reciprocal function. It's just hard to mark and hard to draw. So let's do the domain. We'll do the domain of f of x. You know x cannot be -3. No, on the original, yeah, x cannot be -3. X is an element of real numbers. Range y such that y cannot be -2. Y is an element of real numbers. The inverse x is an element of real numbers. Range, now it's just sort of because I know the domain of f of x becomes the range of the inverse. Range of f of x becomes the domain of the inverse. Is the reciprocal a function? Well, it passes the vertical line test. So we don't have to worry about restricting the domain to make the inverse a function, because the inverse is a function, so that makes part D easy. Let's get off the internet.